Students, today we will discuss about the timeline of sun-like star. So if you check the life cycle of sun, it starts from gas stage. Gas and dust accumulate to form a protostar under gravity, and once a balance is formed between the radiation pressure due to the nuclear fusion and the gravity, a star is born, which you consider as main sequence star. So sun belongs to main sequence star. And after that, once its core is depleted of hydrogen, it will form a red giant star. And then helium flash occurs due to the fusing of helium in the core to the carbon. And this will continue, and the star will behave as a variable star before it finally becoming as a red giant. And after that, it will turn into a planetary nebula, and then it will end as white dwarf. So this is the projected timeline of sun-like star, protostar, then main sequence or adult star. Then gradually it will become a red giant after variable stages between helium flash, red giant, and then it become finally a red giant. After that, a planetary nebula will be formed, and then it will end up as a white dwarf. So today we will look at how a planetary nebula and white dwarf are formed. So after becoming a red giant star, when the star is completely depleted of all its helium fuel, it will become as a blotted red giant for the last time, and then it will throw off some of its mass. Okay, it will completely throwing off its mass, and the star's outermost hydrogen envelope, enriched by heavier elements, fly off into space. Okay, an electrically charged particle stream away in a flow called stellar. So after it is completely depleted of helium fuel, the outer portion of the hydrogen envelope will be flying off into the space. And the deeper layers, that is centermost parts, are thrown off in a wispy, expanding, glowing shell of gas. മറ്റേത് ജസ്റ്റ് ഒരു സ്റ്റെല്ലാർ വിൻഡ് പോലെയാണ് ഔട്ടർ ഷെല്ല്, ഔട്ടർ എൻവലപ്പ് പോകുന്നത്, വളരെ ഫീബിളായിട്ടുള്ളത്. But in the inside, it will expand and it will be thrown off as a glowing shell of gas, typically about 0.5 to 1 light years across. And such a glowing shell of gas thrown out of the red giant is called a planetary nebula, and it will be spreading out. In the earlier picture also it is evident, it will be thrown off like this apart from the core. So that is called planetary nebula, and this is called cat's eye nebula because it has the nature of cat's iris, appearance of a cat's iris, and it is a planetary nebula formed by death of a star which is of the same mass as the sun. So it is thought that the sun-like star would end up like this. This will be the end, the ending stage of a sun-like star or sun itself. So the last, after becoming a planetary nebula, the core will be remaining there. So that will become a white dwarf. So that is the final stage of happening. So after the star has thrown off its gas envelope, the core of carbon, why carbon? Helium has been converted into carbon, completely carbon. So surrounded by a shell of burning helium. So that particular core, which has exhausted of all its nuclear fuel, cannot no longer withstand the pull of the gravity. So what will happen? It will begin to contract. Once it contracts, it will be pulling the matter towards center. So in that process, what will happen? Pressure will increase, and so will the temperature. So as the temperature increases, inside of atom you have electrons. So even the electrons will be stripped off from the atoms. So it will consisting entirely of electrons. So this small, dense, dying star of low luminosity, because there are no nuclear fusion happening, so it will be low luminosity, high surface temperature, because it is very small in size, it has contracted to a size of Earth, and it is called a white dwarf. So it is made up of electrons and nuclei. കാരണം ആറ്റംസിനെല്ലാം തന്നെ സ്പ്ലിറ്റപ്പ് ചെയ്ത് ഇലക്ട്രോൺസും ന്യൂക്ലിയസ് ആയിട്ട് മാറി, which can be skews much closer together to the size of Earth but with a mass that of Sun. So mass സണ്ണിൻ്റെ തന്നെ ഉണ്ട്, ബട്ട് സൈസ് ഇസ് വെരി ലെസ്. അപ്പോൾ അത്രയും കോൺട്രാക്ട് ചെയ്തിട്ടുള്ള ഫോമിലാണ് ഈ വൈറ്റ് ഡ്വാർഫ് സ്റ്റാർ ഇരിക്കുന്നത്. ഓക്കെ, so let's have a concluding session on how a low mass star or a sun-like star will evolve from the main sequence. So during the main sequence, a hydrogen fusion will happening to become helium. That is the energy source. And after that, once hydrogen is completely depleted in the core, the hydrogen fusion will be happening only in the shell around the helium core, and then that stage is called red giant. And once helium core started burning into or fusing into carbon, while hydrogen fuses to helium in the shell, so this will happen, this will cause a helium flash. And after that, it will be leaving, it will be throwing off mass once the helium is also depleted, and those throwing off is called, of the envelope is called planetary nebula, and this will be leaving behind a white dwarf core. So the core is highly contracted, which is in the size of Earth, while the mass will be still that of Sun. So this is how you can depict the stellar evolution in HR diagram. So you can draw the HR diagram with absolute magnitude in the y-axis, and in the x-axis you have spectral class. So you can name it as O, B, A, fine girl, kiss me. Okay, and you can draw the main sequence over here. So from the main sequence, a sun-like star belongs to G's category. So you can mark the Sun along the G stars. So Sun, once it undergo helium hydrogen fusion, and once it is completed of depleted of hydrogen, it will come to the giant stage. But it has not come to the giants for a stable time. It will continue to evolve as helium flash. Then once helium flash happens, it will come to the giant stage. Then again that process will come, repeat, and once helium try to become carbon, and once it is depleted of helium, it will become a planetary nebula, and after that a planetary nebula will be throwing off the envelope. So what is left will be the white dwarf. Okay, so from Sun to the giant stage, and in which helium flash will also happening, and then it will come to a stable situation for the giant stage, then it will become a planetary nebula, and then it will come back to the white dwarf. So this is how the evolution of Sun, stellar evolution of Sun, is represented in HR diagram. While if you just diagrammatically depict the evolution, you just have to mention as we have did for this particular case, you just have to show like this, like from the gas stage to the protostar, then to the main sequence star, then red giant, then helium flash occurs, then variable star, then it will become red giant, then planetary nebula, and white dwarf. Okay, so that ends today's class. Thank you.